and welcome to another CADimensions Lunch and Learn. My name is Derek Welker, and today we're going to be discussing the ins and outs of assemblies. So what I wanted to talk about today was not really getting in depth of creating assemblies or anything like that, but more some of the verification tools that are found within inside of SOLIDWORKS assemblies, so that you can help design your model or kind of help use some of these tools that you might not ordinarily or regularly use. So the agenda for today is we're going to start by talking about like collision detection and how we can determine our static and dynamic interferences, and then we'll get into talking about hole alignments and hole alignment tools, so you can determine if you've got some sort of hole misalignment going on. We'll talk about the assembly visualization tool a little bit, and then also some clearance verifications. Like I said, more of these evaluation and verification tools, so that to help you create these assembly models. Then we'll kind of finish it off with some assembly level features and just some like tips and tricks as far as editing things inside of assemblies and how to go about doing so. All right, let's first talk about collision detection. So collision detection is used to determine dynamic interferences. When I mean dynamic interferences, I mean if you have components that actually move. So you have physical movement going on and you want to determine if any of these components are colliding. So it's located in the move component tool. I think it should probably have its own specific tool, but for now it's going to be right inside of the move component command. You have the ability to stop the collision or stop at collision and highlight faces to be turned on. So what you'll see here is in the top, I'm kind of grabbing the wheel and we're kind of moving it around, but you can see in the U-joint portion itself, there's two faces that are highlighted blue, and that shows you where the interference is occurring and highlights it up and then lets you know that you need to address that specific area. Now, if you start at a port or at a part of your model that's already intersecting, then you either have to move it out elsewhere and then start, or turn off the check between components. So let's hop into SOLIDWORKS and let's take a look at this model here. So you can see that this assembly moves around, but we want to check to see if we have some interferences. Inside the move component command, we just turn on collision detection as part of our options. I'm going to check between all components, and I'm going to make sure that I stop at collision. Now we do have the ability to turn on sound, so it'll yell at us if it, or you hear something, if or when the collision actually occurs, but you won't be able to hear this. Now as I drag this and move this over, you can see it stops. I can no longer move this. I can go the other way, but I cannot move it any further. The highlight faces do pop up as being blue, and now you know where the error is actually occurring. Now if I move this so they're in interference already, and I go move component, collision detection, and I try and move it, it says, hey, the model started in a colliding position, stop on collision has been disabled. So it's just letting you know, hey, you already have interferences. Now if this occurs, this is where you'd go into maybe interference detection and see exactly where your model is interfering with each other, so that you can determine what's going on with it and where you might need to address it. So we talked about collision detection, how you can determine any sort of physical movements inside of your models. Right? And we talked about some of the other settings that you should know when using this tool that's going to be very beneficial. Interference detection. Interference detection is a way to determine your static interferences. So like with collision detection, I called that dynamic interferences or anything that's physically moving. Interference detection is just going to be parts that actually have static interferences. So you made them together and something's a little bit too big. Now let's talk about some of the other options. We have the ability to ignore hidden bodies. So if you have things hidden on purpose, you can make sure you turn those off so those do not get included inside of this tool. You can also have the option to treat coincidence as interference. So if you do have faces that are touching and you want to have a gap in there, you can see what might actually be interfering, even though they're really not physically overlapping. And then we have the ability to ignore. So you can, if you maybe use treat coincidence as interference, you're going to get a lot of interferences. but you can actually ignore a whole bunch of them if you don't want to see them, and then next time you run the tool, you won't see those. But you do have the ability to turn those back on to see them later on down the road. Alright, so let's hop over into my flashlight model and let's take a look at this. Now, the interference detection is found under the evaluate command, or evaluate tab, sorry. And under interference detection, we can just calculate this, and it's going to give us 2 interferences. Now we have the interferences on both sides. It tells you which components are interfering and even gives you a nice highlight. This is a quick and easy way to determine if everything is sized appropriate or if you do have anything that's overlapping that you definitely need to address. Now in this case, this is where I'd go in and maybe shorten up that little tab that goes in there, or I can throw on some additional cuts to shrink that down, right? Or we can do some sort of intersect command or something like that that would eliminate those. So right here down in some of the settings, we have ignore hidden bodies components, and then treat coincidence as interference. If I do turn on treat coincidence as interferences, I'm going to get a ton of interferences. Right? We can also exclude specific components if we want, and then if you just wanted to click on or specify specific components, you can do so here. By default, it grabs your entire assembly, but you can obviously change that so it does not do that. So interference detection, we talked about the static interferences, and if you use the interference detection alongside of the move component collision detection, you have all of your detection things built in. So you can see if you have any interferences as the part's moving, but also any interferences just from overlapping geometry. So they work kind of hand in hand with each other. Now let's talk about the hole alignment. So if you have 2 holes that are slightly misaligned, you use the hole alignment tool to determine if a bolt's not going to go in there or a screw's not going to go in there. Now the great thing is that it actually doesn't only work with hole wizard holes. It can actually work with simple holes and even cylindrical cut features. The only caveat to using this is you must resolve lightweight components. So if you do have a fairly large assembly and you do have a lot of lightweight components, it's going to ask that you resolve those lightweight components to be used. Now using the tool, you specify your hole center deviation, and anything under that deviation is going to be highlighted. So if you specify that deviation because if you have holes that are somewhat close, you don't want those to be picked up as misaligned holes. So you want to make it small enough so that it's going to pick up on some of those misaligned holes. So let's take a look at how this works inside of SOLIDWORKS. So if I go into my hole alignment tool, which is still on the evaluate command, it tells us, hey look, you need to resolve your 17 lightweight components, just like I had already prefaced with you guys. So once all of those loads, we can go ahead and calculate this. Now when I calculate this, I have it on 10 millimeters and it just says there's no misaligned holes. But if we drop down this value and calculate it, then we'll see that we do have some slight deviation of a couple of these holes. So what you can see, this is a nice tool that if you're putting in holes inside of the parts themselves, that you can verify if you've actually placed those in the correct location, so that after you go through tooling or everything like that, you don't realize that you can't screw bolts together or something like that, or screw these in or have fasteners for any of this. So obviously this can be a really useful tool instead of actually having to go through and determine if they are aligned. Right. So I think this is a super helpful tool, but we'll talk about maybe some ways that you wouldn't have to use this in just a second here. So let's talk about assembly visualization. So assembly visualization is more like a chart that you can sort your entire assembly by specific criteria. It does have customizable properties. Now the great thing about this is you can see what has the most mass in your component or in your assembly, what has the most quantity. The one thing that you see here is I've got graphics triangles, which determines or shows you what is the biggest resource or tax on your machine. Now the great thing is you can color code this. So red's going to be the components that have the most graphics triangles, blue's going to be the least. but you can see that it color codes as it goes through. So you've got some magenta colors, some purplish colors in there, just so you know that there's kind of like a gradient scale of things. But you can also turn on lots of other properties that do have specific values associated with them that you can use to sort. So let's take a look at this. In our evaluate command or evaluate tab, we've got assembly visualization. And what you see by default, it just comes in with file name, quantity, mass. Now I can just say like add column, and this is where we can then specify what specific property we want to use. And we've got a ton here. One of the ones I like to go through is graphics triangles. Also, another one that I like to bring in is rebuild times. So that's another one that you can get in. Hopefully we've got right here, SOLIDWORKS rebuild times. So if I bring this over a little bit, and let me just adjust some of these columns so that it makes it a little bit easier to read here. So we've got our graphics triangles and our rebuild time. Now I can click on SOLIDWORKS rebuild time and it will give us the component that has the highest rebuild time. Now if I click over in the ability to toggle the colors, it'll start toggling. And this is where we can see just graphically what components are going to have the highest rebuild times. So instead of going through and saying, okay, it's holder, and then having to know which one it is, you can visually see on the scale. Now the great thing is we can totally adjust this scale so that it changes colors. We can even add in other colors throughout this. So we can go from red to yellow to blue, and then we can have more of a different scale in here. So there's a lot of properties that are really great in here. Now another thing is we can save this out as like a PDF or an Excel document that we can then use for other things if need be, right? So I like using the graphics triangles and rebuild times because it tells us specifically, what's the most taxing on our machine and what's causing the longest rebuild times inside of SOLIDWORKS. So the assembly visualization tool certainly be beneficial, but you can also use any sort of customizable properties as long as you have some sort of value in there for everything that it can sort by. So clearance verification. Clearance verification determines the minimal acceptable clearance specified between components. So you basically say, okay, this is the minimum value. Show me any sort of clearances between components that is less than this value. Now the great thing is it's definitely easier than manual measuring, because if you have two components and you're like, okay, what's the distance between these, and you have to go in the measure tool and find it out, whereas you can just say, okay, anything that has a gap smaller than 1 millimeter, show it to me. Let's take a look at this. So let me get out of my assembly visualization here and let's talk about clearance verification. Now in my selected components, I can literally just highlight over the area that I'm looking for. It'll grab all those components. I'm going to say 1 millimeter and calculate. Now the great thing is when I select, it only shows the two components that have those, I guess, clearance issues or lack of clearance thereof, right? So these are specifying as being coincident, and then you can see if there is a dimension, it'll show you where the dimension is from, right? So you know specifically where it is. And the great thing is you can see, if you don't have any interferences, but you do want to check to see the clearance between some of these components, just say, hey, look, anything under this is probably a little bit worrying. Show me all of them. So this is a really, really great tool that can show you all of the clearances or lack thereof inside of your assembly. Now, just like some of the other tools, we have the ability to ignore. So like the interference detection, we could ignore a specific interference. In this case, we can also ignore a specific clearance. So this is definitely helpful if you got a lot in there that you just want to ignore, so you can check on them later on down the road. So after clearance verification, we've got performance evaluation. So this is a way, you've probably seen it inside of parts, and we've used it in parts just to determine basically rebuild times. Now inside of assemblies, it's a lot different. It tells you more of like if you're using large assembly modes, how many mates are you resolving, what kind of parts do you have, how many unique parts do you have, because if you have 20 of the same parts, you're really only loading in one part, you're just graphically putting it in multiple scenarios, right? So dependent on how many unique parts you have to total number, that can certainly help with your basically assembly speed. So it's basically used with larger or more complex assemblies, and the great thing is it can suggest possible actions that you can take to help the speed or performance of your assembly. Now, one thing to take note of, and this is right from the SOLIDWORKS help page, is that it is important that you weigh recommendations of the performance evaluation against your design intent. So what they're saying is, obviously SOLIDWORKS is going to recommend you something that's the highest performance, but the design intent of your specific assembly might not go well with the intent of performance, right? So you kind of have to weigh the functions or what you're doing with, I know I'm going to do it this way, or use a lot of in-context relations or references or anything like that, but I know it's going to reduce some performance, but let me just limit the amount that I do that with. Right? So you can see 20 mates are evaluated when this assembly is rebuilt. We've got 14 unique parts out of 17. It tells us that large assembly mode is not on, and it just kind of gives us a nice little summary of what's going on. So let's take a look with it, and you just go up to performance evaluation under the evaluate tab, and it gives you this giant list. Now, the great thing is we do have some in-context references, and it actually tells us which specific components we have that have in-context relations, and it tells you how much time it takes to rebuild those. So this is really, really nice, because obviously having some of these in-context relations or references are really, really nice, because they make basically a smart assembly of some sort, but they do require or can hurt performance. So the great thing about using this tool and showing those specific parts, you can see exactly what's denoted by doing it that way. All right, so extremely helpful tool if you're going to go down that road. Okay, last but not least, I want to talk about assembly level features. So there are features that you can do inside of an assembly, and these basically are a way that you would get away from editing in context. So if you wanted to add in some holes into a part, you could do it as an assembly level feature, or you can edit just the component in context. So let's talk about the differences here. Now, one of them being that if you're trying to add material to your model, editing in context or just editing the part or editing the component inside of your assembly is going to be more beneficial because the assembly level features are only for removing material or for only doing cuts. Another thing that is nice is you have hole series. So hole series is a way where you can put a hole and have it go through multiple components, just so that you have, I guess, more control over just a traditional hole wizard hole. So the hole series is specifically meant for assemblies and doing holes through multiple components, so keep that in mind. Now, one of the big and main key things regarding assembly level features is your option to propagate feature to parts. So if you do a hole wizard hole or a hole series or whatever through multiple components, but you want that component in the part level to have those specific features, you need to make sure you turn on the option within inside that cut or whatever feature it may be to propagate that specific feature back to the part. Now, when you go and open up that part, it will have a reference to the assembly for obvious reasons, but you can quickly, instead of having to make 20 holes in each different part, you can make you can just make those holes once inside of the assembly and have it propagate to all of the parts that it essentially goes through. And then we'll talk about external references and how they're handled inside of SOLIDWORKS and how doing something like this affects your external references. So in this case, like if I wanted to add in a hole and propagate it through, so like in this case, I have this hole that was misaligned, right? We determined that this hole was a misaligned hole. So let me go in to my assembly features and let me just throw in a hole wizard hole. Doesn't really matter specifically what it is. Let me just throw this in here. All right, the depth is fine, the size is fine. One thing I want to do is I want to make sure that I propagate my feature to my parts, and if I want to use auto select, that's fine. It's automatically going to pick those two things that it goes through anyway, but if you didn't want to use auto select, you can obviously manually select the components. Now when I hit OK, it does put an assembly level feature throughout both of these, and in this case I must have put it in a location that wasn't very, very well. So let me just go ahead and move this really quick. Whoops, wrong wrong option here. So just for the sake of argument, we'll just keep going here. So you can see that, you know, this hole is obviously not misaligned, but it did put a feature in both of these, right? So taking a look at the feature here, you can see it does get propagated back to that specific component, right? And you can see that there's an arrow here. This arrow signifies that it's got an external reference back to that assembly. Now, if you right-click on it, you have the ability to list your external references. So this is where you can see all of the references inside of the assembly and where they're going to. Say, okay, this feature is referencing this face of this specific component inside of this assembly, right? So you can see all of the references that are going on. And if you do want to break those references, you can select on any one of them, break all, or just specify specific ones and get rid of them. So this is how SOLIDWORKS handles your references. Now, just kind of a preface here. If you do have something like this going on, if you were to open up just this single component, because you have references back to the assembly, that assembly needs to open in the background so that this model can then be rebuilt. So if you have this component that's referencing another component inside of an assembly and that component references something else, then you have to, okay, this part has to open, then it has to open this other part, but it has to be in context of the assembly, and then and then that other part, because that other part needs to rebuild, it needs to open up another part. So you can see, you know, if you stack up a lot of these external references, that opening a file as simple as this could take a long time just for references sake. So it's just one thing to consider when doing this. So this is not for everybody, but you know, if you're doing something very small and you want to just put in a couple holes and not have to do it on every single part, obviously this functionality or this option is very, very helpful and useful. All right, that's all I got for today, guys. If you have any questions, please feel free to ask them at this point. Leave a message or ask me a question, or you know, reach out to one of your CADimensions offices just to ask some specific questions. And I hope to see you guys on the next Lunch and Learn. Have a great day.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.